Today, we want to look at linear and exponential functions, continue looking at linear and exponential functions. Remember, we're thinking of linear functions as that pattern of repeated addition, which we summarize with multiplication. Take m times x. That means we add m a bunch of times with the x. What's happening in repeated addition is that we're increasing or decreasing by some fixed amount. We're adding or subtracting some fixed amount. We're always adding the same amount. This is similar in exponential functions where we're always doing the same thing. In exponential functions, we have repeated multiplication. We're always multiplying by the same amount. But there's another way that we can look at exponential functions, which is important because we describe functions this way all the time, where we can represent an exponential function if things are increasing or decreasing by a percentage. This makes sense because when we increase by a percentage, we have to do a multiplication. So if we want to know 20% of something, we multiply the something by 0.2, 0.20, 20 per 100. And we think about percent as per 100 or divided by 100. So calculating a percentage uses multiplication, so it makes sense that repeated multiplication, or an increase or decrease by a percent, we should represent with repeated multiplication, and that means an exponential function. All right, so let's think about how this works. Let's just start off with a nice simple example. Let's write a description of something that could be increasing by a percentage. Let's say that y equals 100 when x equals 0. And let's make an increase or decrease by percentage statement. And let's say that how things are changing, we'll say, and y is increasing not by some fixed amount, but by some percentage, increasing by 10% every unit. We'll just start off by going every unit. So here's a description. Y is 100 when x is 0, and y is increasing by 10%. So we're going to add 10% every unit. So we will add, not add 10, but add 10% every unit. So let's make some calculations. So we're going to start off with 100. And we're going to add a certain amount. We're going to add 10%. We're going to add 10% of 100. So I need to know what 10% of 100 is. So of means multiply. So when I go down here and I calculate 10% of 100, so I could take 10. Percent is divided by 100. Of is multiply. So 10 over 100 times 100. This we usually write as 0.10, and we'll multiply by 100. But we're just taking this statement, 10% of 100, and translating that into math operations. 10% per 100. Of is multiply, and then 100. 0.1 times 100 is 10. So when we add 10%, we add an amount 10. So we end up at 110. The way I like to remember things is that per is divided by, of is multiply. Per. and cent is 100. So when we go from 100 to 110, that's an increase of 10%. It's also an increase of 10 units because I started with 100. But now when we go from 110, we're not going to add 10% of 100. We're going to add 10% of what we got. So we're going to add 10%. But now we don't have 100. Now we need 10% of 110. So now I need 10% of 110. So I need 10% of 110, and that's 11. So I'm going to add 11. So we add 10 in the first step, but we add 11 in the second step. Because 11 is 10% of what we got, which is 110. In the third step, we're going to add 10% of 121. So we're going to add 10% again, but now we have more, so the percentage is going to increase as well. So we need to calculate 10% of 121. So 0.1 is 10%. Of is multiply, 121, is 12.1. So we add 12.1. So 132.1. So what we can see is that even though we're adding the same percentage, the amount that we're adding is increasing. We're not adding the same amount, we're adding the same percentage. So as y increases, the percent that we add is increasing as well. So if we want to add 10% of 132.1 to get what's going on in the fourth step, we need 10% of 132.1. So we need 10% of 132.1, and then we'll add that to the 132.1, 145.31. This is an important thing to think about because we're increasing by a percent, and we describe a lot of things by, we describe the changes by percentages quite a bit. We talk about how the population is increasing by a percent, and more relevant to your interests, especially if y'all are young people, we describe how an investment would grow by percent. We might say that an investment is growing by 10% every year. So if we start off with 100, in the first year, it grows by 10% of 100, which is, so it'll grow to 110. But in the second year, it'll be growing by 10% of 110. So it's not just growing by $10 again, it'll grow by $11. Then in the third year, the growth will be 12.1. So the amount of increase is also increasing because we're taking a percentage of the total amount. So as y increases, the amount that we add also increases. Now what we need to do is see how this becomes an exponential function. So let's take a look at this same set of information. Oops. Apparently I didn't finish erasing. So continuing with this example, I've made a bold claim that this increasing by a percentage should yield an exponential function. That means there should be multiplication in the change. We should be multiplying by the same amount each time. So if I start off at 0 and 100, then we went to 110, then an increase of 10% went to 121, and then 132.1, and then I forgot what it was already, 145.31. So the description that we had, I used the wrong color before because my increase and decrease by percentages are usually in purple. So we're adding 10% each time, this is just us saying increases by 10%. And I've made the claim that we're multiplying by something. So that raises the question. So if this is increasing by percent is some multiplication, I should be able to figure out what we're multiplying by. I have 100 times something is 110. I just need to figure out what the multiplier is. And I can get there by dividing. So 100 times multiplier is equal to 110. And so that means the multiplier is 110 over 100, 1.10. So in that first step, we did multiplication by 1.10. We can do that in the second. Let's check in the second step. From 110 to 121, what did we multiply by? And we do the same thing. The multiplier should be 121 divided by the previous value of 110. And if I take 121 divided by 11 is going to be 11. So 121 divided by 110, 1.1. So that was a multiplication. That increase of 10% was a multiplication by 1.10. In the third step, if we do 132.1 and divide that by 121, we get 1.091. Did I have the right number? That was the blank page. I'm glad these kinds of mistakes get recorded. 121, 10% of 121 is 12.1 plus 121 is 133.1. It's going to change by 145.31. So that should actually be 146.41. So what we found out is that I'm questionable about being able to add 2. So that page. This should have been a 133.1. Polynomials would have told me that, and the same thing happens here, 146.41. So our multiplier, if I take the 133.1 and divide it by the 121, we see our multiplier is still 1.1. Now that I've fixed all my mistakes. This is because 2 plus 1 is 3 and not 2. So we can see that in each step, increasing by 10%, doing plus 10% is the same as multiplying by 1.10. And the last one, just to make sure that everything got fixed correctly. If I take 14641 and divide by 133.1, we get the 1.1. So when we see something is increasing by a percent, we can translate that into multiplication. In this case, we saw increasing by 10% led to a multiplier of 1.10. What we want to be able to do is translate increasing by a percent into multiply by a multiplier. So if we see something that says increase by some percent, let's call it rate percent, is the same as multiply by 1 point rate. We could make a formula for this, but it's better if we don't have to rely on things like formulas. Formulas are especially not for things that we want to be able to do by observation. So if I say something increases by 12%, that we can translate to multiply by 1.12. If we have an increase by 8%, that means we should multiply by 1.08. Now we could have decimal percentages. I think tax in San Mateo County is like 9.5%. If we want to increase something by 9.5%, then we'll multiply by 9.5% is 0.095. So we'll multiply by 1.095. The 1 means we're adding to what we already had. The 1 represents the amount that we always had. So if we start off with 121, and we want to add 10% of 121, I can factor out the 121. I can say there's a 121 times 1. I want the whole amount because you got to pay that whole thing. And then we'll add 10% of 121. So a lot of times the question is, where does the 1 come from? The 1 comes from the fact that you're not just paying the tax. The 1 is there because you're not just paying the tax. So that's a one way to think about where the 1 comes from. The 1 is there because you're not just paying the So that's one way to think about where the 1 comes from. We're adding to the amount that we started with. So we can see how the plus 10% turns into multiply by 1.10. Here we have the increase by 10%, and that turns into multiply by 1.10. So I have 1 plus 0.1. This is how we would write increase by 10%. And this is equal to 1.10, which is multiply by 1.10. This brings us to the next thing. What happens if we're not paying, after we pay the tax, we also get a discount? What if before we pay the tax, or maybe we're in Nevada and there is no tax? What happens if there's going to be some discount? What if something is going to decrease by 1%? So what if something says, we say decrease by 10%? So decrease by 10% means we're going to subtract 10%. So whatever we start with, say 121, we start with 121, we can subtract 10% of the 121 that we started with. If I factor out the 121 here, what's left is 1 minus 0.1. And so that's 121 times 0.9. So decrease by 10% is multiply by 0.9. So if we want to decrease by 8%, we'll multiply by 100 minus 8, or 0.92. Kind of think about what we're keeping. If we're subtracting 8%, we're keeping 92%. If we decrease by 15.7%, if we think of, if we're subtracting 15.7%, we're keeping 84.3%. So we'll multiply by 0.843. The reason for this is that multiplying by 1 doesn't do anything. Multiplying by more than 1 will create an increase. Multiplying by less than 1, but more than 0, will cause things to decrease. So the big idea is that 1 is in the middle of multiplication. One is the middle of multiplication. Multiplying by 1 does nothing. If we multiply by more than 1, we'll see an increase. If we multiply by less than 1, but more than 0. We'll get a decrease. In that sense, 1 is the middle of multiplication. Similarly, 0 is the middle of addition. So just to tie this together with things that we've seen before, 0 is the middle of addition. So if we add 0, no effect. If we add something more than 0, we see an increase. If we add less than 0, which is subtraction, we'll see a decrease. So 0 is the middle of addition. The math words for this are, these numbers are the identities. 1 is the multiplicative identity. One is the multiplicative identity, because under multiplication, 1 doesn't do anything. And then we want to say that 0 is the additive identity. Zero is the additive identity, because when we add 0, nothing happens. When we identify some kind of operation, sometimes we like to identify what the identity for that operation is. That is, what value doesn't do anything under that operation. That's more than we need to know. What we need to be able to do is take a description where there's an increase or decrease by some percent and turn that into multiplication. That's what we need to be able to do. That's our algebra survival skill. Need to, might not, I don't know, it depends. What you need to do is different. That's going to vary from person to person. But you should be able to translate an increase or decrease by a percent into some multiplication so that you can understand how this works. We need to understand exponential functions because we need to understand when things are changing by percentages. When we talk about giving people, when you're working and you're asking for a raise, you're going to ask for a raise in terms of a percentage based on what you're actually making. If you're in a company where they say don't talk about your salary, notice that the company is only telling you that to protect them. As soon as the company says, hey, don't discuss your salary with anybody, the first thing you need to do is go discuss your salary with everybody. Say, how much you making? How much you making? And then you'll find out that the company values you differently. Then you all need to get together, go to the company and say, hey, I noticed that my coworker is making $10,000 more than I am, and we do the same job. So you now have to pay me $10,000 more. And it works best if everybody walks into the boss's offices and say, hey, we notice that we're all doing the same job, but we're not getting paid as much as Bob over here. So you're going to start paying us that rate. You know what I mean? Everybody's like all apes together strong until it comes to talking to the boss. Then we're afraid for our job. So don't be afraid for your job. All right, what are we talking about? Yes, increasing by a percent means, or decreasing by a percent means an exponential function. We need to understand how exponential functions work because that's how we describe most of the things. If you make an investment or if you're shopping around for different investments to build a retirement account, the growth on that account is going to be based on a percent. They're not going to say it's going to increase by $1,000 a year. They're going to say that it's increasing by some percent per year. Then they're going to kind of hide the fact that it's going to increase by some percent, and then we're going to take some percent of that every year. So that's what we need to talk about. We need to talk about how exponential functions combine with polynomials so that we could start putting money away for retirement or just start investing for our future. So that'll be tomorrow. That's going to do it for today. I will see you all on tomorrow. Everybody have a good day, and thanks for playing.